All right. Good morning. Hope you're off to a good start to the week already. Monday, bright and early, or whenever it is you're watching this on Monday. But wanted to make a quick video here for section 12.4, and we'll meet tomorrow, Tuesday. Refer to the Google Classroom to make sure you know what time that is. But we'll plan to meet and go over some more problems together as part of the homework that we'll do tomorrow for 12.4. So let's just get right into it. I'll share the screen. We're going to do surface area of pyramids today. So kind of similar to what we've been doing. So it shouldn't take us that long to go over what we need to know for today. But first, let's just look at a pyramid here. A pyramid has the following characteristics. All the faces except the base intersect at one point called the vertex. So as you see here, that this point that all these faces intersect, that's called the vertex. Okay, and then we say the base is always some kind of polygon. In this case, the base happens to be like a square. The faces that intersect at the vertex are called lateral faces. So this face of this pyramid and these four faces that I get, the four sides of this pyramid basically are what we would call lateral faces. So let's draw that in here and put that in your notes. That's a lateral face. We said this down here was a base. And then we have these other things that we say that since the faces that intersect at the vertex are called lateral faces and are triangles, we did that. The edges of the lateral faces have the vertex as an endpoint called the lateral edges. So these are the lateral edges, all right, things on the sides. So we can mark that down too, like this one. This is a lateral edge. So we'll mark that. Okay, then I need to know something for today. Oh, well, let's do this first. We have the middle line straight down, and we'll call that the altitude because that's measuring the height, right? Okay, you see that it comes down and it's perpendicular to the base and it goes to the vertex. But I also have another line that I can draw in here. Do that one in red and see if it shows up. A little easier to see that this line that comes down along the lateral face that's perpendicular to one of these sides down here, we're going to call that the slant height. Sorry, the slant height. Okay, and that's going to be important today, and you'll see why in a second. Slant, that's a L. Okay. So we have those things, those characteristics of a pyramid, all right? So let's see what we're gonna do to find the surface area of these pyramids. Well, if I wanted to find the surface area, I'd do the same thing that I've been doing, and I'd find the lateral surface area first, the area of all the sides of this thing put together. So we have four triangles, right, that make up each lateral face. So I'm just gonna put them together like this. They're all the same, okay? They all have the same length here. That's that length right there. So we will just call that S. And so how would I find the area of a triangle? I'd need to know the height. So in this case, this is that slant height that we were talking about. And so we'll just draw these in here on all four of these sides. And so they're all going to be the same. Those slant heights will be the same in each of those triangles, as well as the base. So how would I find the area of one of these triangles, like this one right here? Well, that's easy. I would just take half the base, which in this case is the same as the side. So we'll just use S times the height of this triangle, which is the slant height, or L. Doesn't matter what letters we put in there. You get the idea. We're doing half the base times the height of this triangle. That's all. All right, so we've got some more here. We've got, oops, let's get that back to the pen. We've got another one of those right there. We have another one for the third triangle, which is the same. And we've got another one out here for the fourth triangle, okay? Well, that looks a lot to me like we could just rewrite that as, if I factored out that and the slant height, I would just have that times, the four sides. Well, what's another way of saying the four sides? Look at our original figure. Four sides. What is that? It's the perimeter of the base, right? So in essence, to find the lateral area of a pyramid, I'm going to take half the perimeter and multiply it by the slant height. Okay, and we'll say right over here, just so we know, that stands for the perimeter, and the L stands for the slant height. Okay, and of course I forgot the I in there, perimeter. Okay, so this is how I'm going to find the lateral surface area right there. So, and then if I was going to find the total surface area, then all that's left to do would be to find the area of the base, which is very simple in this case. It's just the side times another side, base times height. It's a square, so it'd be like two sides multiplied together. Or if it was a rectangle, it would just be base times height or whatever. So I just need to find the area of the base, and that would give me the total surface area. So but let's just start with this. Let's start with this idea of finding the lateral surface area. Let's go to number 2 on page 702 and just say, okay, let's find the lateral surface area, okay, of this figure right here. They've got a pyramid. It looks kind of like this. And we'll try to draw it as best we can. There's a leg behind it that we can't see, but we've got 4, and we've got the altitude of this thing is 7. Okay, that's the figure of number 2. We're going to find the lateral surface area of this figure. Okay, so to do that, I need to do 1/2 the perimeter times the slant height. Well, what is that slant height right there? Let's make it a different color. Let's say, okay, how am I going to find that slant height? Well, look, I've just cut out basically like a right triangle right there. And I know that the height of this triangle is 7. If I could figure out what it was from here to here, I would be able to figure out by using Pythagorean theorem what the length of that slant height was. That's the hypotenuse. Well, this happens to be 2 because this whole segment down here is 4, and so half of that is obviously 2. So this segment in here is 2. So let's use that information to find the length of that slant height. So I have 7 squared plus 2 squared equals the area of the slant height, or sorry, the length of the slant height. So I got 49 plus 4 equals that, 53. So it looks like the length of that slant height is going to be the square root of 53. Now let's just put that in and multiply that by the perimeter of the base. What is the perimeter of the base? Each side is 4, so the perimeter is 4 times 4, which is 16. So let's go and put that information in. The lateral area then would be half the perimeter, which is 16, times that slant height, which is the square root of 53. And I'll just put that into my calculator. 8 times the square root of 53. 8 times the square root of 53. 58.24. So 58.24 would be the lateral surface area of this figure. Let's keep going. Let's just go ahead and find the total surface area of this figure. And just all I would need to do now is just add the area of the base to this. Well, the area of the base is simple, 4 times 4, 16. So let's take my answer, 58.24 of the lateral surface area, and add 16 to that. And I get 74.2, approximately 74.2 feet squared, or square feet. So that would be the total surface area. All right, so not too much new. Let's try another one real quick. Let's say number 3. Okay, find the surface area of this pyramid. Draw it in here real fast just to help us a little. Okay, we've got a slant height it looks like, of 3 root 2. We have an altitude height of 3, and that's all we're given. Okay, well, let's remember how we're going to do this. We're going to take the lateral surface area, and then if I'm trying to find the total surface area, I'm just going to add that to the surface or the area of the base. So lateral surface area, how am I going to find that? We said in a pyramid, the lateral surface area is 1/2 the perimeter times that slant height. Okay, well, I've got the slant height. It's 3 root 2. What's the perimeter? Man, I haven't been given any side length. I haven't been given any of these things to find the base. How are you going to do that? How are we going to do that? Well, let's take a look at this triangle right here that I just drew. That's a right triangle. Oh, and I've been given 2 of those sides. Let's find the third using Pythagorean theorem. Some of you might see what the answer is going to be, but for those that don't, let's go ahead and go through this. Let's say that, okay, let's call this side A. So we have a squared plus the b squared, 3 squared, is equal to 3 root 2 squared, right? 3 root 2 is the hypotenuse. All right, now let's just figure this out, what our A side would be. This is 9, this is 18. 3 times the square root of 2 squared would be 18. Okay, so A squared equals 9, A equals 3. Now, how many of you saw that ahead of time because you recognize that this is a 45-45 right triangle? And since the hypotenuse was the length of the side times root 2, you knew that this one was going to be the same, that was going to be an isosceles right triangle. So what's the perimeter? If this length is 3, this length is 3, the whole side has to be 6. So the whole one side is 6. 6 plus 6 plus 6 plus 6, or 6 times 4, that's 24. Lateral surface area is half the perimeter, which is 24, times that slant height, 3 root 2. And now let's do that. 3 root 2 times 12, basically. 3 times the square root of 2 equals that. We're going to do it times 12. 50.91. 50.91. 50.91, that's my lateral surface area. Now let's just add that to the area of the base. Area of the base, 6 times 6 is 36. So let's take my 50, point that, add 36, and I get 86.9, basically. 86.9 surface area of that pyramid, and we were having centimeters squared. All right, I think we're good. However, I'm going to do one more for you because there's one tricky thing that might get you tomorrow when we start doing these together, which we could do tomorrow, but I'm going fast, so I've got some time. Let's do one more. Let's do number 9. I have a hexagon base this time. Mix it up. Or sorry, that's a pentagon. 5 sides. 1, 2, 3, 4, 5. Yep, number 9. Okay, I've got, this is a hexagon pyramid like that. Excuse the drawing. I've got a slant height. And not given, I have an edge of this pyramid, which is 8, and the lateral edge 8, and a 6 along each side of the base. It's a regular pentagon. Okay, it said it at the top. Each thing is a regular pyramid, so the pentagon on the bottom is regular. All right, let's just do what we have been doing. We need to find the lateral surface area of this thing. Then we'll find the area of the base and add those 2 things together. So the lateral area is going to be 1/2 the perimeter times the slant height. All right. Okay, so let's figure it out. If we can figure out the perimeter, that's easy. 6 times 5. Each side is 6. There's 5 sides. 6 times 5 is 30. So we've got the perimeter is easy. We just need to figure out the slant height. Well, looks like if you can take out my, I'll just draw the triangle over here again, like that side. We got a 6. We drew my slant height in there, which I don't know, but I know that that's 8. Okay, well, this is half of 6, so that's 3. It looks like a right triangle, so I should be able to just do this again and say figure out what my slant height is here. I get 55. So there's my slant height. Don't circle that, it's not the final answer. Okay, so that's my slant height. Let's put that in here and say, okay, it's the lateral area is going to be 15, half of 30, 15 times the square root of 55. So 15 times the square root of 55 gives me 111.24, 111.24. So the lateral surface area is 111.24. Now we're going to add that to the area of the base. How do I figure out the area of a regular pentagon that has one side 6? Anybody remember last chapter? You loved doing this. That the area of a regular polygon is the perimeter times the apothem, right? So I got to figure out what that apothem is. Let's make a triangle here. Well, how am I going to find out what this is? Well, this is the distance from here to here is half of 6, because the whole side is 6, so that's 3. Now, how would I find the length of that apothem? That's a right triangle, but I don't have the second side to be able to use Pythagorean theorem. What else am I going to do? Thinking, you're thinking. Some of you are hitting the screen saying, just figure out what that angle is and use tangent. Oh, okay, that's a good idea. So let's make a full triangle there. What's this whole angle? If all the way around is 360 and I have 5 sides, I would do 360 divided by 5, which is 72. Okay, so the whole angle is 72, but I cut the angle in half. So now this angle right in there is half of 72, or 36. So now I can use tangent to find out what my apothem length will be. So let's say tangent of 36 degrees should be equal to opposite side 3 over the apothem, we'll call it A. Okay, so now let's just multiply this out, and I get the apothem times the tangent of 36 equals 3 divided by tangent of 36. Now let's do that on my calculator to find the length of that apothem. 3 divided by the tangent of 36. 3 divided by the tangent of 36. 4.13. So this is 4.13. So that's the length of the apothem. It's not the area of the pentagon. I need to times that by the perimeter, which we already said was 30. So the perimeter, 30 times that, let's do that. That's the area of the base of the pentagon, 123.87. 123.87. So now my surface area is that times 123.87, the area of the base, times or plus the lateral surface area, 111.24, 111.24, and I get 235.11. And sorry, it took a break there to come back. But anyway, let's get back to this. So we were trying to find the area of that pentagon. I'm putting my screen back on. We did make one mistake. When I added this together, we forgot that the area of a regular polygon is half the perimeter times the apothem. So that's fine. We'll just do that. So instead of that being 200 something, let's do 123.87 divided by 2. 123.87 divided by 2, and then add that to 111.24, and we get 173.2, 173.2, and we're dealing in yards, so square yards. Total surface area of that pentagonal pyramid is 173.2 square yards. All right, if you kind of had a good idea of what we were doing before, I feel like you should have a pretty good grasp of this. We didn't do anything new except we had a different way of finding the lateral surface area because we're dealing in triangles and not like squares or rectangles. So we needed to take half of the perimeter times the slant height to find that lateral surface area. So, all right, we will see you tomorrow morning. Have a good day. That's all. Turn in your notes when you are done with this video. See ya.